Hello students, welcome to all Scholar classes. So today I will be taking the second part of materials, metals and non-metals. This is the chapter 4 from class 8 science. Today we are going to discuss the chemical properties of metals. In this we are going to see reaction with oxygen, reaction with water, reaction with acid, reaction with base and also the displacement reaction. In between I will be also discussing about rusting, how red oxide is formed and what is basically rusting, and metal oxide and its nature. That some of the metal oxides are there which have some exceptions, that also I shall be discussing. Okay, so let's start with reaction with oxygen. So first we will see reaction with oxygen. Okay. So for this we are going to do a small experiment. Just hold any of the metal, either it's a aluminum or a copper, iron, lead or magnesium, zinc, sodium, with a pair of tongs and try burning over a frame. Okay, just take a frame and take any of the metal and just try to burn it like this. Okay, so the metals which we are going to use are aluminum is there, oxygen is there, aluminum is there. We are taking right now only metals, okay? Copper is there, iron, lead is there, magnesium and zinc and sodium, okay? So just take a burner and try to hold these metals one by one with a tong and try to burn them. Okay, so first one by one you are going to take all the metals, aluminum, then copper, then iron, lead, magnesium, zinc and sodium. Okay, now we have to collect their products. Okay, the products that are formed after heating them. So let's see the product and the metal surface cool down. Okay, let the metal surface to cool down and let's see what happens. So we are going to see that almost all these metals, they are going to combine with oxygen to form metal oxide. Okay, so what is going to happen? Metal reacts with oxygen to give metal oxide. Fine. So let's take some of the example. सबसे पहले अल्युमिनियम ही लेते हैं. Let's take अल्युमिनियम. Aluminum plus oxygen, it is going to give aluminum oxide. Okay. Aluminum oxide it is going to give. Okay. You need to just balance the reaction. So we have reacted aluminum with oxygen and it is going to give aluminum oxide, means a metal oxide. Next, let's take the example of copper. If you react copper with oxygen, again you will get copper oxide. Okay. So this copper oxide is a black oxide. Okay, fine. This copper oxide is a black oxide like this. If you are going to see the reactions, all of them, all these metals, they are going to react with oxygen to form metal oxide. Okay. So which color flame you are going to see that the metals burn? So these metals, when they burn, they give a blue flame. Fine. The flame which we are going to get is a blue flame. The surface of the metal is going to appear after burning as a silver white, silverish. Okay. So the surface of the metal after burning is going to appear silverish. Okay. Now what we have to do, we need to arrange these metals in the decreasing order of their reactivity towards oxygen. We will see that which which metal reacts most and which reacts least with the oxygen. So we are going to see that the sodium, it reacts maximum, okay, then magnesium, fine, then aluminum is there, then zinc is there, okay. So the maximum reactivity is shown with sodium, fine, then iron and lead is there, and in the last copper is there, and copper gives the least reactivity. Least reactivity with oxygen is of copper and maximum reactivity with oxygen is of sodium. So all the metals do not react with oxygen with the same rate. It's not that all the, if it is a metal, it is going to react with the same rate. No. All of them have a different rate. As you can see that sodium reacts maximum, copper reacts minimum. So different metals shows different reactivity towards oxygen. Metals such as if we take potassium is there, sodium is there, they react very vigorously. Okay, whenever oxygen, they come in contact with oxygen, they react so vigorously that sometimes they catch fire. They react so vigorously. Okay, if they are kept in open and they come in reaction with oxygen, they are going to catch fire. Okay, hence to protect them and to prevent accidental fire, they are always, you must have seen that, immersed in kerosene oil. Okay, so we have seen that all the metals react with oxygen, but the rate of reaction or the reactivity rate is different. Okay, different rates हैं सबके reaction के, कुछ जो है कि बहुत ज़्यादा react करते हैं, कुछ कम react करते हैं. Okay, but some metal oxides, okay, like this aluminum oxide, zinc oxide, show that they react much. Okay, magnesium, sodium is there, they are reacting at a very high rate. Okay, so this was about reaction with oxygen. Okay, so let's see about rusting. Okay, so you all must be familiar with the word rusting. Okay, rusting is a very common word. You all must be familiar with the phenomena of rusting of iron. You must have seen at your home that if you keep any iron material in water or air, it gets rusted after some time. So what is basically that? Why rusting takes place? Okay, so if we take some metals, we all know that metals like magnesium or iron, okay, especially iron, they form oxide when they react with oxygen. Okay, plus oxygen, it is going to give what? Magnesium oxide. Magnesium oxide. Okay, let me write the reaction also. So if you take Mg plus O2, the product form is MgO, that is magnesium oxide. Okay, similarly if you take iron, Fe, that is the iron, plus oxygen, it gives iron oxide. Iron plus oxygen gives iron oxide. Fine. So Fe plus O2, it is going to give Fe2O3 plus hydrogen gas is being released, H2 gas. Okay. So Fe plus O2 gives Fe hydrogen gas is also released. So you can see that iron is also giving iron oxide, magnesium is giving magnesium oxide. Means in both the cases oxide is formed. Okay. So now we shall see the concept of rusting. So let's check the nature of rusting, whether it is a acidic nature or it's of basic nature. Okay. So we shall see some reaction for that. Result of the reaction of iron and oxygen and water. Okay. Iron, oxygen and water का क्या result होगा reaction का? So for this you need to do a simple experiment. Just collect a spoonful of rust. Junk जो होती है घर पे कहीं भी, उसको just you take it a spoonful of rust, dissolve it into a little amount of water. What you need to do that? You need to put that rust in a water. What you are going to see that the rust remains suspended in the water. Means it is not going to float down. It remains on the upper layer of a water. It remains suspended on the water. Now what you have to do? You need to shake it well. Shake it and see the suspension. Okay. So when you shake it, just take litmus paper. Okay. Take a red and blue litmus paper, drop it and see. What do you observe? Is the solution acidic or basic in nature? So what you are going to see that the solution is basic in nature. Okay? Means it is going to turn the blue litmus paper to red. So what we can say that basically what rust is. Okay? If somebody asks you to define rusting or what is rust, so let's see what we can define rusting. Rust is an iron oxide. क्या है? Iron oxide. Rusting क्या है? Iron oxide है. Usually a red oxide. Which color? Red oxide. Usually a red oxide. Okay? Formed by the redox reaction. Which reaction is going to take place? Redox reaction of iron and oxygen. Iron and oxygen in the presence of moisture or water, you can say. Okay? In the presence of water. I have just now told you. I have shown you that if you iron plus oxygen plus water, all of them were involved. So rust is an iron oxide, usually a red oxide, formed by the redox reaction of iron and oxygen in the presence of water. Okay? So the chemical nature of rust is, rusting का chemical nature क्या होगा? Basic. It's basic in nature. Okay? So we got to know that this is basic in nature. Okay, rusting is basic in nature. It means that if it is basic in nature, does all the metal oxides are basic in nature? Anybody can answer me? Because iron oxide is also an oxide. It is basic in nature. So is all the oxides are basic in nature? So the answer is no. Most of the metal oxides are basic in nature, but some metal oxides are not. They show both acidic as well as basic behavior. Okay? So next we shall be seeing this. Metal oxide, behavior of metal oxide. Okay, we are going to see that whether the metal oxides are behaving as a acid or as a base. Okay, so we oxide mostly are basic in nature. ओके, पहली चीज तो है कि मोस्टली जो मेटल ऑक्साइड्स हैं वो बेसिक होते हैं नेचर में, बट few metal oxides like aluminum oxide is there, zinc oxide is there. Okay, aluminum oxide and zinc oxide, they show both acidic as well as basic nature. Okay, they show acidic as well as basic behavior, or you can say they show acidic as well as basic nature. Okay, so some metal oxides which reacts with both acid to produce salts and water and bases to produce salt and water are known as, this type of metal oxides are known as amphoteric oxide. What are they called? Amphoteric oxide. Such metal oxides are called as amphoteric metal oxide. Okay, so let's see how aluminum reacts to show acidic nature also and basic nature also. Okay, so first we are going to take aluminum oxide, that is Al2O3, and first we are going to take any acid. Let's take hydrochloric acid. HCl we have taken. Okay, so it is going to give AlCl3 plus H2. So you can see here salt plus water is being formed. Okay, now let's take a base. Again aluminum oxide we have taken. Let's take a base NaOH and let's see the reaction. So here sodium aluminate will be formed, that is NaAlO2, sodium aluminate plus H2. Okay, this is sodium aluminate. So you can see here also that salt plus water is being formed. So we can say that this aluminum oxide, it is reacting with the acid also and with the base also to form salt plus water. So since it is behaving as a both acidic and basic nature, this type of oxide is called amphoteric oxide. So this aluminum oxide is a amphoteric oxide. It is a amphoteric oxide. Same is the case with zinc also. It is also an amphoteric oxide. Okay, so we are seeing the behavior of a metal oxide. The first thing we have seen about it, its acidity and basic nature. So most of the metals are basic in nature, but few metals behave as acidic as well as basic. Such type of metal oxides are called amphoteric oxides. I have shown you the reaction, how they are reacting with an acid also, that is the hydrochloric acid, and with a base also, that is NaOH. Okay. Now let's see the second point about a metal oxide. Behavior of a metal oxide. Okay, so most metal oxides are insoluble in water. Most metal oxides are insoluble in water. Fine, but some of these dissolve in water to form alkalis. So most of them are insoluble in water, but they dissolve in water to form, what do they form? They form alkalis. Okay, so example is aluminum oxide, copper oxide, iron oxide, lead oxide, magnesium oxide, zinc oxide. All these are not soluble in water. Okay, so most metal oxides are insoluble in water, we have seen, but there are few they are soluble, that they dissolve in water to produce alkalis. So the example is sodium oxide and potassium oxide. This sodium oxide and potassium oxide, they are soluble in water. Okay, they dissolve in water. So let's see the reaction. First we are going to take sodium oxide, that is Na2O, okay, plus water. We are seeing its dissolution in water, whether it is going to dissolve or not. So it is going to form an alkali, that is NaOH. Okay, a salt is formed. Fine. Similarly, we are going to take potassium. Similarly, we are going to take potassium oxide. Okay. So K2O plus H2O, it is going to give KOH. It's again an aqueous solution and it's a salt. So you can see here that sodium oxide and potassium oxide both are forming alkali oxide, that is salt they are forming. Means they dissolve in water, whereas most of the metal oxides, they do not dissolve in water. Okay. So this was about the behavior of a metal oxide. We have seen its acidic and basic nature, that most of the metals are basic in nature, but few of them show acid as well as basic nature. Okay. That type of metal oxides are called amphoteric oxides. Here again, if we see the solubility in water, most metal oxides are insoluble in water, but still few exceptions are there and they are soluble in water. So here we have seen about sodium oxide and potassium oxide. Now we have seen how rusting takes place. I have already explained to you about rusting and how it occurs in iron. Okay. Now I would like to discuss about copper vessels. Okay, what is going to happen to our copper vessels? We have seen about iron vessels or about iron rod, anything which is when exposed in air, it is going to be rusted. So if we talk about copper vessels exposed to the moist air for long, what does it occupy? A copper vessel. आयरन में तो हमने देखा कि रेड ऑक्साइड फॉर्म हुई, रेड रस्टिंग फॉर्म हुई। जब कॉपर ऑक्साइड को आप एक्सपोज करेंगे लॉन्ग टाइम के लिए एयर में, तो क्या एक डल ग्रीन कोटिंग बनेगी, डल ग्रीन कोटिंग विल बी फॉर्म। ओके, exposed in air. When it is exposed in air, a dull green coating is being formed. Okay, so this green material is a mixture of copper hydroxide. It's a mixture of copper hydroxide and copper carbonate. What is this? It's a air, oxygen, carbon dioxide and oxygen both are going to be there. Okay. So the solution forms are copper hydroxide plus copper carbonate. Okay, CuCO3 and this. So this one is a moist air. Okay. Moist air is there. So this is about copper vessels. We have seen about iron vessels also. Okay. So this was all about reaction with oxygen. Now let's discuss reaction with water. So let's see reaction with water. Okay. So metals like aluminum, copper, iron, lead, magnesium, zinc, sodium, all are taken together. So what do we see that all the metals they react with water to produce metal oxide and hydrogen. Hydrogen gas is also being released. Okay. So metal oxides are soluble in water, as I have already shown you that they dissolve further to form metal hydroxide. Okay, so all metals do not react with water. All metals they do not react with water. So metal plus water is going to give metal oxide plus hydrogen gas. Okay, and this metal oxide plus water, if you take, what does it is going to give? It is going to give metal hydroxide. Okay, so metal plus water gives metal oxide plus hydrogen gas is released. Metal oxide plus water gives metal hydroxide. Okay, so for this let's do a small experiment. Put a small pieces of sample of all the metals which we are having separately in a beaker, and let's see which metal reacts with cold water. We will see that calcium reacts less violently. Okay, the heat evolved is not sufficient for the hydrogen gas to catch fire. Okay, let's see the reaction of calcium with water. Ca plus H2O. Okay, what is it is going to give? CaOH2 plus hydrogen gas will be released. H2 gas is there. Okay, so this is the water. Okay, this was about calcium, but calcium reacts very less violent. Okay, or some of the metals they produce fire when they react with water. Okay, so these metals are potassium, sodium. They react most violently. Okay, potassium and sodium we have seen that they with oxygen also they were the most reactive, and in water also they are the most reactive. So in case of sodium and potassium, the reaction is so violent and its exothermic reaction is there. So hydrogen evolved immediately to catch fire. Okay, this hydrogen gas evolved immediately catches fire. Okay, so let's see the reaction of potassium plus water. Okay, so what is formed when potassium reacts with water? KOH. Okay, and hydrogen gas is released, and the reaction is as I have already told you, exothermic reaction means heat energy is released. Okay, another we can take the example of, first I will be labeling it 2K. is a gas, so you should always write this gas aqueous solution. Similarly, let's see for sodium. Okay, Na is there, H2O, so NaOH plus H2 gas plus heat energy is again evolved. Okay, let's balance the reaction. So we have seen that calcium reacts with water, but it does not react vigorously to catch fire, whereas potassium and sodium, it reacts so vigorously and an exothermic reaction takes place where there is a release of heat energy, okay, and it is going to catch fire immediately as soon as this hydrogen gas is being released, okay. But there are some metals that do not react with hot water, okay. So we shall take see the examples of them that they do not react with hot water, neither they react with cold water, but they react with steam to form metal oxides and hydrogen. We have, okay, metal oxide and hydrogen is formed not with water, neither with hot water, not with cold water, but what they are going to do, they react with steam. So I will be giving you that example also. So it's iron and aluminum, two such metals which react with steam to form metal oxide and hydrogen gas. Okay. So let's take aluminum when react with water. What it is going to give? Al2O3 plus hydrogen gas is being released. Okay. So the reaction is being balanced here. Okay, aluminum we have seen. So in this case, water was there, here also cold water was there, and here the water is a steam. Fine. Another example is iron. If you take iron, same thing is going to happen when it reacts with water. It's give iron oxide. Fe3O4 plus hydrogen gas is being released. Fine. So these are reactions of metals with water. Okay. So we have seen that calcium also reacts less vigorously, potassium, sodium more, aluminum and iron reacts with steel. But there are still some metals that do not react with water at all. Okay, so I would like to name them, like lead is there, copper is there. They do not react with this. Ag, iron and gold both are there. Okay, so they do not react with water. Although they are a metal, but they do not react with water. Fine. So this was about the reaction with water. Reaction of metals with water. First we will see with metals, then we will see with non-metals. Next, let's see reaction with acids. Okay. So metals react with acid to give salt plus hydrogen. Okay. So dilute acid, it is going to give salt plus hydrogen. Okay. Metals react with acids to give salt plus hydrogen. But do all metals show this property? No. All the metals metals react with the same manner, almost all the metals react with the same manner, but still there are some metals that do not behave in this procedure. I will be telling you further which are they. So let's take the example which behave in this. Magnesium is there, iron, zinc is there. These are the metals that produce salt plus hydrogen when they react with dilute acid. Okay, but what are the exceptions? If we see, we shall be seeing them further. First, let's see the reactions for them. Okay, so magnesium एसिड में हम ले लेते हैं, हाइड्रोक्लोरिक एसिड लेते हैं. So it gives magnesium chloride MgCl2. It is a salt. Okay, salt is always written Aq, that is it is in aqueous form. Plus hydrogen gas is released. Okay, so let's balance the reaction. So magnesium hydrochloric acid is giving magnesium chloride and hydrogen gas is being released. Similarly for zinc, if you take plus hydrochloric acid, okay, again what will be formed? Zinc chloride. Plus hydrogen gas is being released. Fine. So zinc is there, hydrochloric acid, it gives zinc chloride. Fine. Plus hydrogen gas is being released. If you take for iron, Fe plus hydrochloric acid, again iron is also going to give iron chloride. Okay. फाइन, हाइड्रोक्लोरिक एसिड से रिएक्ट करके क्या बनाएगा? ये आयरन क्लोराइड बनाएगा, FeCl3 plus H2 gas. Okay, so these are the reactions to show that metals react with dilute acid to form salt and hydrogen. Here you can see magnesium chloride, a salt is formed, zinc chloride and iron chloride, a salt is formed, and in all the cases hydrogen gas is evolved. Now the question is which acid, which metals do not react in this behavior. So hydrogen gas is not evolved when metal reacts with nitric acid. Okay, जब हाइड्रोक्लोरिक एसिड से मेटल रिएक्ट किया तब तो हाइड्रोजन गैस रिलीज हुआ, बट जब नाइट्रिक एसिड से हाइड्रोजन गैस रिलीज करेगा, रिएक्ट करेगा मेटल, तो हाइड्रोजन गैस नहीं रिलीज होगा. Why is it so? This is because this nitric acid is a strong oxidizing agent. What it is? It is a strong oxidizing agent. Okay, it oxidizes very soon and it oxidizes hydrogen to produce water. हाइड्रोजन जो है, जो हाइड्रोजन गैस बननी है, उसको ये ऑक्सीडाइज कर देगा और क्या बना देगा? वाटर. तो हाइड्रोजन गैस की जगह जो है कि वाटर बन जाएगा और अपने आप को इट सेल्फ रिड्यूस टू नाइट्रोजन ऑक्साइड. ओके, कोई भी नाइट्रोजन ऑक्साइड हो सकता है, N2O, NO, NO2. ठीक है. सो मैग्नीशियम एंड मैग्नीज दे रिएक्ट विद dilute nitric acid. Okay, to evolve hydrogen gas which is further oxidized to form nitric acid. Okay. Okay, so this was about reaction with acids. Fine. So we have seen reaction with acids. Now we will see reaction with bases. Okay, so for base we are going to take sodium hydroxide, that is NaOH. Sodium hydroxide. Okay. So what we have to do that we need to prepare a fresh sodium hydroxide NaOH in a test tube by dissolving 3 to 4 pills of it in a 5 ml of water. Okay, 3 to 4 pills of sodium hydroxide plus around we are going to take this pellets plus 5 ml water. Okay. So now what we need to do, we need to drop a piece of aluminum, as a metal we are going to take aluminum into it, okay, into this hole. So what will happen when we bring a burning matchstick near this the mouth of the test tube, what we are going to observe? We will see a pop sound. What does this pop sound indicates? This indicates which sound we are going to see? This pop sound. So what does this pop sound indicates? Pop sound indicates that there is a presence of hydrogen gas. Somewhere there is a hydrogen gas. When you bring the matchstick near to the test tube, you are going to hear a pop sound which indicates that there is a hydrogen gas. So metal reacts with sodium hydroxide to produce hydrogen gas. It means that metal reacts with base. It is a base to give a hydrogen gas. But the reaction of this bases with all of the metals is almost possible. Okay, they react with sodium hydroxide to give bases. Non-metals we shall be discussing later on. First we will see about metals only. Okay, so next we are going to see the displacement reaction. Fifth type is the displacement reaction. So what happens in displacement reaction? Again we are going to do some experiment. So what we will do, take a clean wire of copper and an iron nail. We are going to take a clean wire of copper and iron nail. Okay. So what we are going to do that in the copper wire solution, we are going to add iron sulfate, and in the iron nail we are going to put copper sulfate. अपोजिट रखेंगे दोनों में, ठीक है? और आफ्टर 20 मिनट्स जस्ट रीड द ऑब्जर्वेशन. कॉपर नेल में क्या है? आयरन सल्फेट, और आयरन नेल में कॉपर सल्फेट. ओके, सो दिस टाइप ऑफ रिएक्शन इज अ डिस्प्लेसमेंट रिएक्शन. व्हाट वी आर गोइंग टू सी दैट the reactive metals can displace less reactive metal. जो ज़्यादा reactive metal है वो less reactive metal को displace करेगा from their compound solution or their molten form. So all metals are equally reactive. All the metals are not equally reactive, as we have seen in so many reactions in oxygen, in the case of water also, that they are not equally reactive. Okay, so now we will check that the reactivity of various metals with water and acids also, and even oxygen also we have seen. They are not reactive with all of the metals. Okay, so what is going to happen in case of displacement reaction? We will see the reactivity of metal here also. So it is simple and easy. If suppose let's take an example. Metal A is there and metal B is there. Okay, so what is going to happen? Metal A will displace the solution of metal B if metal B is more reactive. If metal A is more reactive, then metal B will displace the solution of metal A. A plus metal B. Okay, fine. So I have told you this is going to happen. So suppose let's take copper sulfate. Okay, कॉपर सल्फेट है, मेटल ए मान लीजिए आप, सोल्यूशन कॉपर सल्फेट सॉल्ट ऑफ सोल्यूशन बी को मान लीजिए और प्लस जिंक ग्रेन्यूल्स एडेड. ओके, और दूसरा केस क्या हो सकता है कि आपके जिंक ग्रेन्यूल्स हो गया और कॉपर सल्फेट हो गया. दूसरा हो सकता है जिंक सल्फेट plus copper granules. Okay, fine. So like this displacement reaction takes place. जिस मेटल का ग्रेन्यूल है उसका सल्फेट नहीं होगा, अदर वाले को होगा, और जिसका सल्फेट है उसका ग्रेन्यूल नहीं होगा. So like this, अगर आयरन सल्फेट है तो कॉपर ग्रेन्यूल्स है, कॉपर सल्फेट है तो आयरन ग्रेन्यूल्स है, like this only. So this was about the displacement reaction that one displaces the other, which one is more reactive. Okay, so we have seen here the reactions of metals in which we have discussed reaction with oxygen, water, acid, base, and the displacement reaction we have seen. 5 types of reaction we have seen. Now in the next session we shall be discussing about the non-metals reaction. We will be seeing how non-metals they react, and this will also be discussing some of the features of metals and non-metals in that. Okay, so this was all for today. Here our part 2 get finished. Okay, thank you so much for watching my video. If you like my video, please give a like button, and if you have not subscribed our channel yet, please do subscribe Ollie Scholar so that you can get the daily updates of the videos. Okay, I would also like to add on that Ollie Scholar has got its app. Just go in the Google Play, download the app. It's with the name CSCS e-learning. You can get the videos, PDF notes are there, and MCQ question. If you are interested for online test, you can give that also. And another thing is that you can also join up with the live classes if you are interaction. We are here with one-to-one interaction with teacher and student. So thank you so much. Thank you for watching my video.